So we're going to talk about confidence intervals. Starting off, we're going to look at a 95% confidence interval. We're looking at a normal distribution here with unknown mean. We don't know what the mean is. However, we do know that 95% of the time, if you remember the empirical rule, 95% of our data lies within 2 standard deviations of the mean. So 95% of the time, if I'm taking a sample out of this population, I'm going to get a sample mean within 2 standard deviations of the mean, even though I don't know what that is. So let's take a look at the first sample that we do. So this is the sample that we get. Notice that it is within 2 standard deviations. This is the markers for 2 standard deviations. It's within that. So when we go 2 standard deviations to the left and 2 standard deviations to the right. And notice that it does include the population mean. Okay, because if we don't know this value, we really don't know when we take a sample if we're dead on or if we're to the right or if we're to the left of that population mean. We don't know. But 95% of the time, we're going to get something within 2 standard deviations. So if we go 2 standard deviations on each side of that mean, then 95% of the time you're going to capture the true mean. And that's basically the underlying principle of a confidence interval. So let me do a few more here. Another sample, the sample mean is just a little bit lower. We went 2 standard deviations, again we called it. This time we got a sample mean that was below the population mean. But when we went 2 standard deviations on each side, it still captured, inside this interval, we captured the population mean. This one's almost dead on the population mean. So once we go 2 standard deviations to the left and 2 standard deviations to the right, well, of course, we're going to capture it. So I'll do some more here, and I'll actually go ahead and do a sample of 50 now. 50 times. The ones that are in red, this was our sample mean here. Sample mean is slightly outside 2 standard deviations. So when we go 2 standard deviations to the left, 2 standard deviations to the right, we don't capture the true mean. So how often is that going to happen? That's going to happen about 5% of the time, because 95% of the time it is going to capture it. Notice that we have the percent hit here is 89%. If we do another 50, notice that only 2 out of those, this is doing for the whole thing, but out of this 50, only 2 of them didn't meet. And so that's 2 out of 50 or 4 out of 100. That's 96% of those met. Okay, so over the long term, about 95% will capture the true mean. So if we looked at a 80% confidence interval, notice that we get more reds. It means it did not capture the true mean more often, because we're only 80% confident. 20% of the time, it's not going to. So also you can notice that the sample means aren't really any different here. They're about the same thing. But the length of these intervals are smaller. And that's because if you're more confident, the higher your confidence level goes up, then the longer your intervals are going to be. So if I look at a 90, notice they get a little bigger. 95 is what we started with. And then 99, they get even longer. Okay, only this one sample is outside of that. Notice it's way beyond, even beyond, looks like 3 standard deviations, which is very unlikely. We know that it's unlikely to get a sample mean outside of 3 standard deviations. So only about 1% of the time are we not going to capture that. Okay. So we'll look at an example. It says, assume the weights of NFL players have a standard deviation of 20 pounds. Now, going back to this, this isn't very practical to know the population standard deviation, but again, I'm just talking about the concepts here. We'll get into that issue in class. So we take a random sample of size 100 NFL players' weights and get a sample mean of 255 pounds. Now, one thing to know, we don't know what the population mean is. We don't know if 255 is greater than the mean or less than the mean, or if it's exactly the population mean. We don't know. But we're going to find a 95% confidence interval for the true mean weight. Okay. Well, if we know that 95% of the time we're going to get a sample mean within 2 standard deviations, or about 2 standard deviations on each side of the mean. So what we're going to do is take the sample mean and go 2 standard deviations to the left, 2 standard deviations to the right, and that's going to give us our confidence interval. Okay, so again, we're talking about the sampling distribution. Each time you take a sample of 100 NFL players, you don't expect to get the same mean every time. Okay, you're gonna get a different mean, but all of those possible 100 samples that we get, we call that the sampling distribution. Okay, and we know that it is normally distributed because we know that if the size of the sample is at least 30, then it's approximately normally distributed. And since n is equal to 100 here, that's greater than 30, we know that it is actually, this should say approximately normally distributed. But the higher n is, the more normal distributed it looks, so it's going to be pretty normal, but not exactly. So, and the standard deviation of the sampling distribution is 20 divided by the square root of 100. Remember, that was for the sampling distribution presentation, which is 2. So what that means is a typical difference for the sample mean each time you take a sample of size 100 for these NFL players, it differs on average about 2 pounds. That's what standard deviation means here. So we're basically looking at this. Okay, we don't know what the mean is here, but we don't know what z equals. This is z scores, so we don't know what z equals 0 is. We don't know what the mean is, but we do know that it's normally distributed, and we do know that the standard deviation of the x bars is 2. Okay, so if we're doing a 95% confidence interval, we're looking at about 2 standard deviations on each side of the mean. Okay, again, we don't know if 95 is, or 255 the mean, if it's right here. We don't know if it's here. We don't know if it's here. We don't know. It may be outside of 2 standard deviations. There's a 5% chance that it's outside of it. Okay, but what we do know is that if we go 2 standard deviations on each side of that mean, then about 95% of the time we're going to capture it. So I'm going to do an estimate this time. This is 255. And I'm going to go to the left and the right. That's a plus or minus 2 standard deviations. Well, 2, and my standard deviation is 2. Okay, so this is an approximate, because if you remember, the empirical rule says that about 68% lies within 1 standard deviation, about 95% lies within 2, and about 99.7 lies within 3. But it's not exact, but we can get a little more precise in a minute, and we will. But this is 255 plus or minus 4, basically. So 255 minus 4 is 251. And 255 plus 4 is 259. Okay, so that's our confidence interval. And we interpret this confidence interval by saying we are 95% confident that the true mean weight of NFL players lies within this interval. Okay, that's what it means. So I'll also do this. Guess I really don't need the curve here. But, well, yeah, I guess let me illustrate something. So, 95%, the middle 95% is slightly below or inside of 2 standard deviations. And I'll show you how I know that. So right now, let's say we're looking for the middle 95% in the confidence interval. That leaves me with 5% in the 2 tails. That leaves me with 0.025 here and 0.025 here. Okay. So if I'm looking at, I can use my inverse norm function, which we learned when we started talking about the normal distribution. Say inverse norm, and it asks me the area to the left. Well, if I want to know this z-score, the area to the left of that is 0.025. And again, the mean is 0 and standard deviation. I'm in the standard normal. I'm losing z-scores here. So notice that z-score is not really -2. It's negative 1.96, rounded to 2 decimal places. Okay, so I can also find this one. It's going to be the same thing, except positive. But what area is to the left? That'd be 0.975. The 95 plus the 0.025. So if I do 0.975, get the same thing except positive. Okay. So, and I'm not going to do the whole computations here, but just to understand where we're going to get these, what we call z star. So let me do this. We have x bar, which is what our sample mean is, plus what we call z star times the standard deviation of the population divided by the square root of n. Because this thing is the standard deviation of the sampling distribution of x bar. Okay, how those sample means differ from one another. So using that, we have 255 plus or minus 1.96. Now notice you don't have to do a negative 1.96 or a positive 1.96. It's the same thing because you got plus or minus. And then our standard deviation was 2. So I guess I would say this is the more accurate confidence interval than the one before. We had 2 here before because it's roughly 2 standard deviations on each side, but this is a more accurate answer. Okay, so once you get your confidence interval, every time you do a confidence interval, I'll go ahead and do this on the next page. Every time you do a confidence interval, you need to interpret it. And that looks like this. We are 95% confident that the true mean, and whatever your parameter is here, when I mean parameter, I mean we might be talking about the population proportion. If you're talking about that, then you want to say we are 95% confident the true proportion. But in this case, we're talking about the mean. So we are 95% confident that the true mean weight of NFL players lies in this interval. Of course, you have to find the interval first. Last time we got 251 and 259. But if you've already stated the interval, you don't have to put it inside your interpretation. So that's my statement. Now, sometimes you're going to be asked, what does 95% confident really mean? And they'll say interpret 95% confidence, or interpret the confidence level. And what we do there is we say, if we were to use the same methods over and over again, it doesn't have to be exactly this wording, our confidence interval will contain the true mean 95% of the time. Okay, so what is that? That goes back to what we were looking at the beginning. If you were to do another sample, took another sample of 100 NFL players, you probably wouldn't get 255. You might get 254, you might get 258, you might get 260. Okay. But if you go 2 standard deviations to the left and 2 standard deviations to the right of that sample mean, you get another confidence interval. Well, if we did it a bunch of times, just like the original, going back to this, each time you do it, this is what it's saying. 95% of the time, your confidence interval is going to capture the true mean. In other words, this is a 99%. This one's the only one that doesn't capture the true mean. And that's because we got a sample mean that was unlikely. It was out here in the extreme tail.